Hello, my friends. This is Mr. Folly, and welcome to Unit 7, Heat. Heat. Where we're going to look at solids, not solids, and in transition, solids, liquids, and gases. Ha, ha, ha. So let's start off. States of matter. States of matter are determined by temperature and determined by pressure. See how there's two things? The hotter something is, the more likely it is to be a gas. The colder is more likely to be a solid. This is not new information for you, right? You want to boil water? Make it hotter. You want to freeze water? Make it colder. Determined by pressure. More pressure means it's more likely a solid. Water is the only exception. We won't go into that much, but just water is a different little dude. We'll talk about it in class, the weirdness of water. Less pressure means it's more likely a gas. Solids vibrate, right? So these are all at the same temperature. So assuming these are all at the same temperature, stronger intermolecular forces than a liquid and a gas, okay? So if we're at the same temperature, so let's say I've got, we'll say granite. We'll have water, and we'll have nitrogen. At the same temperature, why is granite a solid? It has stronger intermolecular forces, okay? H bonding is the strongest force, then dipole, then dispersion. A little review there. You can only use intermolecular forces at the same temperature to compare them. A solid has a constant volume. Notice how this volume is unchangeable. A constant shape. If I took it out of the beaker, it would look the exact same shape. The movement is vibrational, meaning they never move across each other, and it's the most closely packed. A liquid. Weaker forces than solids, but stronger than gases. Again, we're talking about the same temperature. They have a constant volume. So this guy right here, if this is 30 milliliters, and I pour it on the floor, guess how much is on the floor? 30 milliliters. Right? Variable shape, it fills the bottom of the container. Notice how my spill changed shape. Middle level of packed particles. And the movement is translational. Trans means across. So they move across each other. Gases have the weakest intermolecular forces, assuming you're at the same temperature. They have variable volume. So because the shape fills the entire container, okay? So if in walks Travis. How did I know Travis walked in? I can smell him. Why is that? Because if this is Travis, he emits an odor that fills the entire room. Now you can decide on whether that is stink or whether it's the Axe body spray he loved so much in 7th grade, but that odor would fill the entire room. Okay, and the movement for a solid is rapid, random, straight line motion, and it's the most spread out. Really, a gas is mostly empty space, so I really can't emphasize how empty a gas is. If you are a particle, the next closest one is a mile away. Think about actually having to run a mile. That's far, that's far, that's far. Okay, I'm a little short on time, so I might have to do the videos in class. Melting is solid to liquid. It's endothermic. Energy is absorbed. The intermolecular forces will break, and the particles will spread out. Freezing is liquid to solid. Exothermic, liquid releases heat to form a solid. So what I like to do is I like to say gas, liquid, solid. Whenever I move up, so melting is moving down, that's exothermic. Heat is going out of it. If I'm moving up, that's endo. And when I draw this, I don't get it messed up. Because a lot of times if I think anything that's got a gas, that's exothermic. No. Only gas to liquid is exothermic. It's endo when you go up. Okay. Freezing is exothermic because you're going from liquid to a solid. Liquid releases heat to form a solid, and bonds form, stronger bonds form, and the particle condenses. Boiling, liquid to gas, absorbing energy, right? Energy is absorbed, particles spread out. Condensing, gas to liquid. Hey, I'm going down in energy, right? So gas releases heat to form a liquid, and bonds form. The particles condense. Sublimation of a solid. Sublimation is a solid to a gas. Again, a solid to a gas. Whoa, my goodness, is that going to be, oops, I put it on the wrong side. Solid to a gas, oh my goodness, is that going to be endothermic? I have to absorb a lot of energy to do that. Deposition is a gas to a solid. It's sometimes called sublimation also, isn't that annoying? And it is exothermic. Gas to a solid, high energy to low energy is Accel. And the particles will condense. Okay, potential energy is the energy of position. That's bonds for us. Okay, so like I showed before, this is gas, this is liquid, this is solid. If I were to make up numbers for it, I would say a solid has a potential energy of 5, a liquid has a potential energy of 8, and gas has a potential energy of 300. Okay, that's the kind of difference we're talking about. All right, and this comes from the fact that bond energy is Q1, Q2 over radius squared. These are the same because you're talking about the same deal. But this radius squared, remember how I talked about relative mile away? That means that I'm dividing by a really big number, so my bond energy goes way down. So strangely, gas have the most potential energy, but they have the weakest bonds. So a solid has the strongest bonds, liquid, then gases are way less. Potential energy, solids have the least potential energy, then liquids and gases have way more. So just keep that in mind there. Kinetic energy is the energy of motion, and temperature is the average kinetic energy, and it's measured with a thermometer. And heat is the total kinetic energy, including mass, measured with a calorimetry. So what would melt more ice, a drop of boiling water or the South Campus pool? I hope you would say the South Campus pool. Why is that? It has more heat because it has more mass. A drop of boiling water might be able to melt 1/5 of a cube. But even the cold South Campus pool could melt 100 ice cubes. Easy. Right? All righty. Good. We got to go to our videos. So let's look at our phase changes, solids, liquids, and gases. Here we go. Watch, it's going to take forever. Yeah, it's not taking forever. So, quick break.
The thing that's different about a Verbo vacation home, you always have the whole...
My video notes are brought to you by Verbo. So here's ice cream time lapse. I'm melting. So notice how it lost its shape. Solids have a distinct shape. Liquids take the shape of the container, which is the flat bottom. Look, more melting. Okay, that's good. You know where to find that if you want more of it. Freezing. So oh man. Oh, I don't want to do that though. Let's see if I copy and paste it. Oh, I don't want that. Just that. All right. So this is going from a liquid which has motion, freezing bubbles in slow motion. The music kind of touches my heart. Blow bubble, puff and puff. And you can see the particles are moving, bubbles are moving. There's translational motion moving across each other. They're not getting bigger or smaller. And then look, the freezing is happening. Oh my goodness, it is now starting to stick together. These particles are still moving, but they're just vibrating so small that you can't see them anymore. Oh, what a wonder of science. Oh, tear. Okay, next one. And then condensing. This is gas to liquid. Oh, you dirty dog. It did to me again. Why does it tell me my browser's got issues? All right, Karen, take this. Oh. So then that means we don't get to see sublimation. I'll try it one more time. I'm trying back later. It's later. Will it work? It's still thinking. What's it saying? I got a red YouTube video. It's not available. To which case I will say, toodles. Bye.